Hi guys, today we're going to learn about the related rate. This is a kind of review about the related rates. Why I chose this topic because I gave a quiz, something about the related quiz last time, but then a lot of you kind of like confused about it. So I kind of like decided to give you the short review about the related rates. So this is kind of like a study guide and we went over during the first semester. And if you go to the right section, I kind of like posted under the file so you can actually download it. So this is not the brand new problem. So if you check your binder, you might be able to find out one exactly same as this study guide, and then you can just go back and check your binder and then kind of like go over by yourself if you want to. So here we have a balloon and then it's being inflated. So the balloon is inflated with respect to time, which means that the volume is increasing. So dV over dt, which is a 5, since it's being inflated, we know dV over dt is a positive. So cubic inch per minute, so cubic inch per minute. That's what we're given. So when the radius is a 4, so we are given a radius, so which is a 4. So I try to write down all the information that we're given. How fast is the surface area of the volume changing? So in this case, we need to find out two different formula. One, what is the volume of a sphere? So the volume of a sphere is a 4 over 3 pi r cubed. Sorry about the, the pen. Yeah. So this is the volume of a sphere. So what is the surface area? Surface area, if you take the prime of volumes, then bring down power, the 3 can be canceled out, which is a 4 pi r squared. So that's the surface area, which is what? The first prime of a volume, right? So we can find out the dV over dt, which is equivalent to the surface area. Well, since we are given a dV over dt, we already got the surface area, right? Okay, so dV over dt, I just want to take the derivative of each side with respect to time, which is a 4 pi r squared times dr over dt, right? So since the radius is a 4, and then dv over dt is a 5, so 5 equals 4 pi radius squared times dr over dt. Yeah. So we have 64 pi. So 5 over 64 pi, that is a dr over dt. So the radius is changing with respect to time at the rate of 5 over 64 pi inch square per minute, right? Now, surface area. How fast is the surface area? Is it changing with respect to time? Okay, so let me use the S. Okay, so what they're looking for? They are looking for how surface area is changing with respect to time. That's the question. So which means that we have to take the prime on each side with respect to time, which is a pi r times dr over dt, and then we can just plug in everything. Now the radius is a 4, so r is a 4, that's a given. And from the volume, we already got the dr over dt, which is a 5 over 64 pi. Now let's plug in. So ds over dt is a pi times radius 4 times 5 over 64 pi. So you can cancel them out. And here is 8 and here is a 2. So we have a 5 over 2. That's the, sorry. So this is the rate of what? The surface area, right? So surface area is increasing because a ds over dt is a positive. So what is a unit? So this one is an inch square per minute. So surface area is increasing at the rate of 5.5 inches square per minute. So that's the answer. Now the next example, the sand is being poured onto a beach, creating a cone. So whose base diameter is always twice its height. So what we're given, so the diameter is always twice its height. But then we know we did a radius instead of a diameter. So we know the diameter is equivalent to the radius. So we know the 2r equals diameter. So from there, so we know the radius is equal to the height. And now the sand is being poured at the rate of 20 cubic inches per second. Being poured, so which means the dV over dt, volume of a cone is increasing at the rate of 20 cubic inches per minute. So which means that we are given a dV over dt, which is a 20 positive, when the height of conical part is a 6 inches. So we are given a height, which is a 6. When height is a 6, we know the height and radius increase at the same rate. How do we know? Because if you take the prime on each side with respect to time, dr over dt is equal to the dh over dt. So when the height is 6, we know the rate is 6. Radius is also 6. So we got a lot of information from the first sentence, right? Okay, now, so that's still what we're given. Number A, letter A, how fast the radius of pile changing? So which means what is a dr over dt? That's a question, right? So in this case, we have to use the volume because we are given a dv over dt. So do you remember, do you have the memory of the volume of a cone? So we know that is 1/3 pi r squared times height. So in this case, we might have to use the product rule. But in this case, we don't have to because we are given a clue. So the height is equivalent to the radius. So which means that we can substitute r for h to get rid of h because we don't need a height because we need to find how fast of a radius, which is a dr over dt, right? So I'm going to substitute r, which means that the volume is 1/3 pi r squared times r, which is pi r to the third part. So now I'm going to take the prime on each side with respect to time, which is a carry down power 3, so 3 can be cancelled out. Pi times r squared times dr over dt. Now let's plug in everything. So now we got that since the height is 6, radius is also 6. dv over dt, that's the 20. So now let's plug in. So dv over dt is a 20 equals pi times radius squared, 36 times dr over dt. Now divide each side by 36 pi, which is isn't it 5 over 12, right? 9 pi. So that's the dr over dt. So now, which means that the radius is increasing at the rate of 5 over 9 pi. Isn't it inch per second? Okay, so that's the how fast is the radius is changing with respect to time. So we got that. Now this is A. Now how we can find out B? How fast the diameter? So that we know from there, so the diameter is equivalent to the 2 times the radius. So how we can find out the diameter, which means that we can just multiply that by 2. So the answer is 10 over 9 pi. That's the diameter changing with respect to time. C. How fast the height of piling changing? Now from there, we know the radius is equivalent to the height. So dr over dt equals dh over dt. So C, dh over dt is the same as a dr over dt, which is a dr over dt. Make sure on the AP exam, you have to write down the rate. So all the rate is a what? Isn't it? Inch per second, right? Sometimes they ask you, just rewrite your answer in a sentence, okay? So which means the radius is increasing at the rate of 5 over 9 pi inch per second. That's your answer.